For example 6, it says for the function f of x is equal to x minus 3 over x plus 2, find the intervals of increase and decrease. Well, what do we know about this? We know our original function has an x plus 2 in the denominator, which means that x cannot equal negative 2. We're going to take the derivative of this using our quotient rule, and I'm going to get x plus 2 times 1 minus x minus 3 times 1 all divided by x plus 2 squared. This is going to give me x plus 2 minus x plus 3 all divided by x plus 2 squared. And that's going to give me 5 over x plus 2 squared. Well, I don't have any x values in the numerator, so I'm just going to be doing it for when f prime of x does not exist in the denominator. So 0 is equal to x plus 2 squared, which means that x is going to equal negative 2. Now in this case, remember, it's not really a critical number because it didn't exist in my original function, so we're going to call this a significant number. Where x is equal to negative 2. It's not a point that exists on my original graph, but it still is a perspective point of change. And then I'm going to put that onto my graph or onto my chart, because it's asking when is it increasing, when is it decreasing. And what do I know? I know it's changing at that x is equal to negative 2. So I can go from negative infinity to negative 2, or I can go from negative 2 to positive infinity. I have my numerator is going to be 5. My denominator, I get that x plus 2 squared. I'm looking for my f prime of x and how that's relating to my f of x. So when I pick a number less than negative 2, this is going to be positive, and this is going to be positive. When I pick a number greater than negative 2, this is going to be positive, and this is going to be positive. Which means that this is greater than 0, and this is greater than 0, and this is increasing, and this is increasing. Well, then it looks like it's always increasing. So we'd think that if it's just always increasing, then it's going to be increasing when x is an element of negative infinity to positive infinity. But that's wrong. Remember, it can't actually equal x is equal to negative 2, which means that even though in both these regions it is increasing, we'd still need to state that f of x is increasing when x is an element of negative infinity to negative 2, or negative 2 to positive infinity. It is not increasing when it equals negative 2 because it can't equal negative 2. For part B, when it says the absolute maximum and minimum points for the interval of 3 and 7, well, there are no critical numbers. So we just use endpoints. which means that we're going to state that f of 3 is equal to 3 minus 3 over 3 plus 2, which is going to be 0 over 5, which is just going to be 0. F of 7 is going to equal 7 minus 3 over 7 plus 2, which is going to equal 4 over 9. And because those are the only values that we're using, then that is going to be my min, and that's going to be my max. Which means, therefore, I have a absolute maximum value of 4 over 9 and an absolute minimum value of 0. If we're doing this using a graph, then we need to remember that we're going to include our critical numbers and our significant numbers. Now, for this first graph, we don't see any maximum or minimum points here, but we do have a vertical asymptote that's running along here, which means that we're going to call that a significant number of x is equal to 5. And this is actually negative 5. When I'm making my chart, then it's changing at the point of 5. So I'm going to say I'm going from negative infinity to negative 5 and negative 5 to positive infinity. And I can still state, what is f prime of x doing? What is f of x doing? Well, we can see that when it's less than negative 5, this is increasing, which means that this is greater than 0. When it's greater than negative 5, it's decreasing, so this is less than 0. And we already stated that one is increasing, one is decreasing. When I apply it for the second graph here, I have a vertical asymptote at x equals negative 6. I have a vertical asymptote at x is equal to 2. And I also have a turning point or an actual critical number here from this minimum where x is equal to 2. Sorry, negative 2 here. When I create my chart, then I have 4 intervals to consider. I have when negative infinity goes to negative 6, the first significant number. When I go from negative 6 to negative 2, the significant number to critical number, negative 2 to positive 2, critical number to significant number, and then when it is above 2, and I can see what's happening for f prime of x and f of x. So we can see when we take a look at this that in the first region it is decreasing. In the second region it is decreasing as it moves from left to right, which means that this is going down. This is going down, which means that this is less than 0 and this is less than 0. In the third region, it is increasing, and then once again here, it is also increasing, which means that this is going up, this is going up, this is greater than 0, and this is greater than 0.